For this lesson, we want to talk about troubleshooting motors. We want to talk about the different types of electrical motor problems. We want to talk about the common problems and how to find them in electrical motors. And we want to describe the mechanical problems in these motors. We're going to talk about capacitors and capacitor checkout procedures. We want to explain the difference between troubleshooting a hermetic motor problem and troubleshooting an open motor problem. So let's begin with the electrical troubleshooting. Problems are either electrical or mechanical. Mechanical problems may appear to be electrical in nature. Electrical problems may appear to be mechanical. Technicians must be able to diagnose the system properly and correctly each and every time. Technicians must locate the cause of the problem, which is not always the resulting effect. Mechanical motor problems are the most common problems involving the bearings or drive connections. Bearing failure could be tight or worn bearings, lack of lubrication, might have excessive grit in the bearings, and might have over-tightened belts. They're not often repaired by the field technician. It involves disassembling the motor on a bench and replacing bearings and making sure everything's lined back up. Most often you will not replace these. To remove a sleeve bearing, you put a tool over it, then tool is struck with a soft face hammer, in other words a rubber mallet, and that tool pushes the bearing out. Once the bearing is removed, the same tool can be used to reinstall the new bearing. To remove a drive assembly off of a direct drive motor or a pulley, you have to remove it from the motor shaft. It has to be done carefully as not to damage the shaft. Special pulley pullers can be used, and set screws are tightened to the motor shaft that must be removed. These set screws are made of hardened steel. The end of the motor shaft should never be hammered in order to keep the shaft perfectly round. So with the pulley and a set of pulley pullers, you put the hooks under the pulley and you put the center of the pulley puller onto the end of the shaft. As the screw is tightened, the pulley is removed from the shaft. Over-tightened belts can cause bearing damage. Loose belts can result in slippage. Belt tension gauges should be used, and the drive and the driven pulley should always be aligned. If they're not aligned, the drive mechanisms can become damaged, belt life can be reduced, and belts can slip off the pulleys. Both the pulleys and the driven shaft, if you look at them, are in a straight line. If they're not, remove a set screw on the pulley or on the driven wheel and make sure they're in alignment. Electrical motor problems are easy to diagnose. The motor may spell burned. Common motor problems include open motor windings, a short circuit from the winding to ground, a short circuit from winding to winding. The open winding can be checked with an ohm meter. There should be measurable resistance between the common and start, common and run, and start and run terminals. An infinite resistance reading indicates an open winding. If the motor's hot, let it cool before you take these resistance readings. There might be an internal thermal overload. If any of these readings do not work, you're not going to fix the motor in the field. Just replace it. This is an example of an open winding. If I took a reading from start to run, I would have an OL, or an infinite reading. Then I would take a reading from start to L1. Again, I'm going to have an infinite reading. Make sure you remove any capacitors or components before you take these resistance readings. Shorted motor windings result from holes in the winding insulation. It allows an alternate path for current to be created. Current flow through the winding increases. If the short is in the run winding, the motor may start, but the current draw will be very high. If the short is in the start winding, the motor may not start, but excessive current will be drawn. Now, sometimes these shorted motor windings actually touch ground as well. In that case, you'll have an electrical charge to ground, which should trip a breaker. If you have a short to circuit to ground, there should be no continuity from a winding to ground. Mega ohm meters can be used to detect small, high resistance paths to ground. In damp conditions, dirty motors may have a resistance reading from windings to ground. If refrigerant oil is dirty, hermetic compressors may have resistance readings from a winding ground. Either way, the motor should be replaced. The ideal condition, no continuity from a winding to ground. In this case, we have a shorted winding, which is actually touching the frame of the motor. So here, regardless of what terminal I take the reading on, if I put one lead of my ohm meter on a terminal and one lead on a clean casing of the compressor or motor, I'm going to have a reading. Well, if I have a reading, I'm going to have current flow going to the ground. Motor starting problems are relatively easy to troubleshoot. Check for full power to the motor. If I don't have full power, the motor's not going to start properly. If the motor hums but doesn't start, you might have a starting problem, like one of the start components is not closing. Motor may run for a short time and then shut down, or the motor might not attempt to start at all. If the motor turns freely, examine the electrical circuits. If the motor hums but does not start, the starting components should be checked. Capacitors can be checked either with analog or digital meters. If you're checking with an analog meter, use an ohm meter. Always discharge the capacitor. Either use a screwdriver and touch both terminals together, or use a resistor. A good capacitor will register a resistance reading towards 0, and then the needle will move back towards infinity. If there's no reading, reverse the meter leads. No needle movement indicates an open capacitor. A reading of 0 ohms indicates a short circuit. Now, with the newer digital meters, use your capacitance scale. The reading will be in microfarads. Put the two leads on the capacitor after you've shorted out the two terminals and removed it from the circuit. The reading will give you the actual capacitance in microfarads. It should be within 5% of what the capacitor rating is. Run capacitors, they're encased in metal and are oil filled. If they're swollen, they need to be replaced. The range of these is from 2 to 60 microfarads. Start capacitors are dry. They're encased in bakelite. The overcurrent can cause them to vent or pop. Wiring must be in good conditions for motors. Loose connections can cause system problems. It can result in oxidization on electrical contacts. Oxidization can increase circuit resistance. Resistance increases the amount of heat generated. It can result in low voltage being supplied to the motor, and low voltage can result in increased motor amperage. Hermetic motors represent a special problem because they are sealed. They can only be checked electrically from outside the compressor shell. They experience the same problem as open-face motors: grounded circuits, open circuits, short circuits, and starting component problems. So, in summary, electrical motor problems can appear to be mechanical. Mechanical problems can appear to be electrical. Common mechanical problems include defective bearings or drive connections. Belt tension and pulley alignment must be correct, and electrical motor problems include open windings, short circuits, and short circuits to ground. Defective start components can prevent motor starting. All wiring connections must be good in order to ensure proper motor operation.